Hello friends, welcome to my channel. Let's have a look at a daily challenge problem. That is problem 606, construct string from binary tree. So in this video, we're going to share a solution based on recursion. So the key actually for this solution is prepare the output format. So first, let's read through the statement of the problem to digest the requirements, and then we do a simple analysis and share the code. First, let's look at the statement. So given the root of a binary tree, construct a string consisting of parentheses and integers from a binary tree with the pre-ordered traversal way and return it. So here, another important thing to notice is that we need to omit all the empty parentheses pairs that do not affect the one-one mapping relationship between the string and the original binary tree. So this problem actually is ask us to find a string representation of the binary tree. It's actually also related to binary tree serialization. So here are two examples. Let's look at the first example. So here, this is the tree. So we have one corresponding to this one, and then we have the left subtree is given by the first bracket, and the right subtree is given by the second parenthesis. So in the first parenthesis, so we have a subtree with root 2. So this tree actually has a left child, but do not have right child. So we have 2, and then we just have one parenthesis, that is 4, enclosing 4. So this is example 1. So if we look at example 2, so actually the topology of the two binary trees are different. So here, for the subtree with root 2, so in the first example, it has a left subtree 4. But in the second example, it has only a right subtree 4. The representation actually is different. So here we have 2, then we have an parenthesis, a pair of parentheses enclosing nothing. But this actually takes this position to indicate that we have an empty left subtree, or we can see that so the 4 is actually a right subtree, right? So this actually is a subtle difference in example 1 and example 2, which is also an important point to be noticed of. So with that said, let's look at the constraints, or we can see the additional assumptions on this problem. First, the number of nodes in the tree is in the range 1 and 10 to the power of 4. So this first constraint actually defines the problem size. And the second constraint is on the range of the node value, which is bounded by 1000 in absolute value. So with that said, we are ready to look at the method and do a simple analysis. So the method here is based on recursion. So this problem actually can be solved using an iterative format. But the binary tree is a recursive abstract data type. So here we are going to use recursion. We feel it's very natural. So the key is to prepare the output format, because the problem itself in logic is very simple. But we need to make sure the output format is what the problem requires. Or in other words, we want to get the proper string representation of the binary tree. At least we need to be able to distinguish different binary trees with different topological structure. So the point we need to notice is that, so actually this point is went over during the analysis of example 1 and example 2. So here let's explain in a higher level. So first is that for a tree with left subtree but no right subtree, the representation is the node value plus a pair of parentheses, then the left subtree representation. So we do not need to add extra parentheses for now right subtree as below, right? This is not necessary. So for this, at a point, we can see the tree represented by node 2 in example 1. So this is one point. The second point is that for a tree with a right subtree but without a left subtree, we need the parentheses for the now left subtree to make the full tree and its string representation as isomorphic. So here is the representation. So we have node value. So this parentheses pair represents that this guy is a recursive tree. So for this point, we can see the tree represented by node 2 in example 2 here, right? It has no left subtree but a right subtree. So we need a pair of parentheses enclosing nothing to indicate that this 4 is a right subtree. So with that said, actually we are ready to write the code, but before we do that, it's good to try to write an iterative solution. So it's not very hard. So with that said, let's look at the solution in a recursive format. So I'm going to write with some sort of redundancy, strictly speaking not, to demonstrate the details and the preparation for the output. So first, I'm going to initialize a result variable, which is empty. Then I want to treat a set case or stop condition or base case in terms of the recursion format. So if not root, so we're going to return the result, the empty result. And then we consider the other part. In other words, the tree is not null. Then first, let's consider the special case, if not root left and not root right. So this can be regarded as a base case. So in this case, what we're going to return is nothing but the string representation of the root value. So this is actually very straightforward. So otherwise, if the node has either left subtree or right subtree, so we need to prepare the output or prepare the string representation of the binary tree. So first, I'm going to add this string root value to the result variable. In other words, we update the result variable status. And then we consider the case if not left. So because we have done the if check, so if not left, it must have a right subtree. So in this case, we need to add an pair of parentheses enclosing nothing to indicate that we have a right subtree. So in this case, we're going to return is result plus, so a pair of parentheses enclosing nothing to take up the position of the left subtree. In other words, a null left subtree, and indicate that below is a right subtree. So we're going to enclose the right subtree, right? So before we do that, actually we forgot to do a recursive call. Let's first call the recursive things. So left equals the self tree to string root left. Right is nothing but self tree to string root right. Right. So this left and right can be empty strings if root left and root right are just null. So according to this base condition here. So with that said, we can prepare the output. If not left, so we must have a right subtree. So we are going to add this pair of parentheses enclosing nothing to take up this position to maintain isomorphic between the binary tree and its string representation. Then we add this part. So we add right, and then we plus the closing parentheses. So this is the one case. In the other case, so we have a left. So then in this case, we should return result plus the open parentheses plus left plus the closing parentheses, then plus this one plus right plus. So that's it. So in this case, so yeah, if we like, we can so we have left. So if we do not have right, so we can actually just use this part. So we can actually so if we like, so in this case we have a left. If right, so we can return something like this. So otherwise, so we just need to return this part. So this is actually very detailed and verbose. With that said, we are ready to do some tests. So let's first test a special case. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So that's about it for this specific format of solution to this problem. So here, what we emphasize is that the main point in this problem is to notice these two items or two situations we specified here, and demonstrated in actually the two examples given by the main statement. And then after we realize that the main point is prepare the output. So in this format of solution and for the purpose of presentation, so we actually write the code in a very verbose fashion to prepare the output. We first consider if we do not have left child, but we have a right child, so what we do. And then we consider the case, so we have a left child. If we have right child, what we do. If we do not have right child, what we want to do. So with that said, I guess that's about it for this video. So you are welcome to check out other videos in my playlist or channel. Thank you very much.